Yeah, so welcome, as I said, and I'll go through a couple of slides here presenting the meeting for today, and then we'll turn it over. So thank you, everybody, for joining us from Seattle, from wherever you are. Now that we're online, we've been able to extend this a little bit to a wider audience. So it's, got to find a silver lining in these things. So hopefully you can hear us and see us well from wherever you are. Like I said, welcome to the Seattle Revit User Group for May. We've got a pretty exciting presentation lined up for you today, or at least exciting for me because I'm a bit of a hardware geek. So we've got Puget Systems, who is a new sponsor. We're really happy to welcome Puget Systems to the SeaRUG family. And we've got William George from Puget Systems, who's going to walk us through hardware optimization for Revit. So, what components of your hardware really give you the best bang for your buck in Revit and other BIM users such as VR and things like that. So I'm really excited about this. Like I said, I love hardware. I love tearing things open. I think my father gave me a Phillips screwdriver when I was 6, and I've never stopped taking things apart since. So hardware is just kind of a fun thing for me. So I'm going to really enjoy this, and hopefully you are as well. I want to give a shout out to all of our sponsors who make SeaRUG possible. And really a big thank you to all of them as well for bearing with us in this interesting time of COVID and of doing these meetings online, which like I said, open up the audience a little bit, but take a little bit away from the social and networking aspect. So we really appreciate you sticking with us during this strange time. And also a big shout out and a big thank you to the rest of the SeaRUG board who helped me curate the content and put these meetings together. And I look forward to seeing you all in person again soon, and thanking you in person, and as well as everybody else in membership. So as you know, I like to get out of the way here pretty quickly and give it over to the presenter. But before I do, I want to reiterate, since we are online, we do record these meetings. We do put them up on YouTube if you wanted to share this with colleagues or you wanted to see something again. But I would recommend that you check out the YouTube channel and that you subscribe so you can get notified, like it, subscribe, share, all those good things. We have pretty big plans starting a little bit later this year as far as delivering content through the YouTube channel that is not just the user group meetings. Traditionally, that's all we've posted. If you go on there right now, you'll just see past meetings, but we're going to be putting up some more content, some more in-depth, maybe hardware reviews or tips and tricks, things like that. So go ahead and check it out, subscribe, like it, so you can get notified, and it'll be a good resource for you. And without any further ado, I really want to thank Puget Systems for joining SeaRUG as a sponsor, and I want to hand this over to William. So I'm going to stop my screen share. And I will mute myself and let William come on and become the presenter.
Thank you, David. And hello, everybody. I'm going to go ahead and hit screen share on my end here. And I apologize, my slides are not nearly as pretty as David's. I liked those graphics you were using. I'm a little bit more plain, but hopefully the information here is helpful. And I've tried to put as much as possible of what I'm going to be saying on the slides. They're a little bit dense in terms of text, but the idea there is that if you want to come back later on, you can skim through and read if you don't want to actually sit through listening to everything I'm going to say. Thank you, SeaRUG guys, for hosting us. This is awesome. We're looking forward to working with y'all. And as David was saying, the presentation today is going to be focusing on hardware for Revit in a computer workstation, how to understand what the different components are in a computer, what they actually do, how Revit uses them. And then also we're going to dive in a little bit to some related applications, things that people do alongside of Revit. And then we're going to wrap up with kind of just some specific recommendations on hardware and tips for selecting and configuring a workstation. Whether you're building one yourself, buying one from us or another system vendor or whatnot, just to help make sure you're getting the right thing and not wasting money. So without further ado, let's go in here. And I'll start with a little bit of background about us, just so you know why you should even bother listening to us. We are a workstation manufacturer that specializes in custom high-performance systems for a wide variety of uses, but mostly in the professional areas: engineering, photography, photogrammetry, video editing, game design, things like that. And our focus really is on making sure that you're not just getting a computer, you're actually partnering with us. We'll help make sure that if you have support needs down the road, you're covered. We do lifetime tech support on all of our workstations, and really just making sure that you're freed up to be creative, to get your work done, and not having to worry about the hardware. So that's kind of our niche. And in addition to presentations like this, we have a ton of web information on our website. It's pugetsystems.com, and if you go in there, you can find recommendations for all sorts of different systems, Revit, as well as other software applications. And we also publish a lot of data, testing that we do and other things. So we have a section with articles and a blog and stuff that, again, if you're interested in looking more into these details, has a lot of information available publicly for you. So what we're going to try and accomplish in this webinar today, and I'm hoping to have enough time here. I might skip some of the end stuff if we get pressed for time. I don't want to delay everybody, but the primary focus is going to be an overview of the main components in a workstation PC, how those affect Revit, some specific hardware recommendations, and again, where to spend your money to get the best performance for your budget. The two additional topics we're going to cover beyond just pure Revit itself are rendering and virtual reality. Those are things that I think a lot of people end up doing rendering, or a lot of departments where someone's doing Revit, someone else might be doing rendering. So I wasn't sure how that might sort of be a helpful thing for you. And virtual reality is getting to be more and more popular. Actually, I was just chatting with David about this and his work in VR that he's starting to do before the meeting here. And it's got some different needs compared to just modeling and BIM. So we want to talk about that a little bit for you as well. And please ask questions if you have anything that comes up, something I'm not covering or something that I said but wasn't clear. Feel free to let us know. There's actually a little thing, should be a little bar at the bottom of your screen where you can hit Q&A and ask questions, and we will try to loop around to that at the end, again, given enough time. That's what it'll look like if you're asking a question right there on the slide. So to dig in here, what PC components do and how it affects you or your Revit experience. We'll start off with the core stuff. The CPU, or central processing unit, is the main component in the computer that does calculations. It's like the brain. It can do all sorts of different stuff. And there's two primary characteristics you'll see talked about when you're looking at them. Core count, that's like the number of individual little brains within the CPU effectively. That governs how many different things the CPU can be doing at once. And clock speed, that's just how fast those individual cores can run, how much they can get done per second. Because of differences between CPU designs, Intel versus AMD, different families from each of those manufacturers, and the way software behaves, you can't really just look at core count and clock speed. That gives you some information, but actual real-world testing is even more helpful to see how those are actually used in the field. So how does the CPU impact Revit? Honestly, most stuff in Revit is very CPU heavy. Most stuff in Revit is very CPU heavy, but primarily cares about single-threaded performance. There's not a lot of multitasking going on in most of Revit. There are some exceptions, but for the most part, when you're creating or editing models, exporting, etc., that's primarily using one or just a handful of threads. And most graphics-related stuff as well, when you're viewing and manipulating and rotating models around, that is impacted by the video card, which we'll talk about later, but it is also very, very heavily using the CPU. The one exception, or the primary exception, I shouldn't say the only one, there are other things, but the big exception with the single-threaded and clock speed rule there is rendering. If you're doing rendering within Revit, that actually does scale really well with more CPU cores. It's not perfect scaling, but you'll get substantial gains from having a higher core count CPU. Moving on to the video card, or GPU, it stands for Graphics Processing Unit. That's the chip usually on a video card in a system that handles calculations related to what is being displayed on the screen. So that means it's updating millions of pixels on the screen, depending on what your resolution is, dozens of times per second. Ideally 60 is usually the target. So that's a lot of work that it has to be doing. And they're designed specifically to do a lot of little tasks very quickly at the same time. There's also memory built onto those video cards that is dedicated just for the video card to use. A part of that's as a frame buffer to handle the data that's about to be displayed to the screen, but it can also be used for other things. You'll hear that called video RAM or VRAM for short. And then GPU manufacturers usually segment their products into consumer and professional lines. For example, with NVIDIA, they have the GeForce line for consumer stuff, and then the Quadro line is billed as their professional card line. And unfortunately, Autodesk usually only certifies the professional cards. It's very rare that they will test or list in any of their certification documents the more mainstream GeForce cards. And that is true for Revit as well. Revit uses the video card for displaying whatever's on the screen. It's fairly apparent. We talked about that a little bit already, but that means the smoothness and responsiveness while you're moving around your view, rotating or editing things and stuff on the screen is changing, depends on the GPU. It also, though, depends heavily on the CPU. So it's a blend of the two. And actually had just gotten done a couple weeks ago doing some testing with Revit 2020, and you'll note here, there's actually not a lot of difference with any of the current Quadro cards, all the way from the P1000 up to the RTX 6000. They're all in the same area. And this was done on 4K resolution with a fairly complex model being rotated around. So Revit actually isn't all that demanding on the video card. It will change depending on how complex your models are, how large they are, how much is on screen at once. But in general, it's not going to be a thing where you have to spend thousands and thousands of dollars on a video card to get good performance, thankfully. We'll talk a little bit more about that when we get to specific hardware recommendations later on, but that's something good to be aware of. Higher screen resolution and multiple monitors does put more of a load on the video card, and that can also use more video RAM. You probably wouldn't want to be running a quad monitor setup off a card that only had 2 gigs of video memory, for example. And it's also worth noting that only one GPU is beneficial or utilized by Revit at a time. You don't need it for Revit specifically, and again, we'll get to some exceptions when we talk about rendering. You don't need multiple GPUs in a system to get performance or anything like that. But if you're using other software alongside of Revit, it is worth keeping in mind that different applications will have different usage. And this is what I was actually just mentioning a moment ago. GPU-based rendering is a prime example, and we will talk about that a little bit later on. Then system RAM, which stands for random access memory, is effectively the short-term storage in your computer. That's where all the data related to open programs and files is kept. So Windows, Revit, whatever model you've got open in Revit, web browsers, any other things you've got going on. And RAM is very, very fast to access, but it's volatile. When the computer's shut down, everything in RAM is cleared. And the memory in a computer is sort of a thing where you can have a ton and never end up using more than you need, and that's fine. But what happens is if you don't have enough is where problems start to rise. And what that will do, Windows and whatever operating system you're using, but in the case of Revit, it's usually going to be Windows, will monitor memory usage. And if it starts to get near the maximum that you've got, it'll look and go, okay, what memory hasn't been used in a while? And it'll move that off to one of the drives in the system. And that's great because it helps avoid crashing. Otherwise, if you ran out of memory, the system would just crash when it needed more. But accessing the drive, even a very fast drive, is orders of magnitude slower than the RAM. So you want to avoid that happening if at all possible. And we'll talk about memory specifics here on the next page. Windows itself just needs about 4 gigabytes these days, which is actually quite a lot for an OS, but not a ton by memory standards nowadays. Revit itself, though, the memory requirements are very heavily dependent on the file size you're working with. I would say the absolute minimum, if you just want to be able to open Revit and a small file, is 8 gigs of memory these days. But 16 is what we would consider our minimum, and I think the minimum that we allow on configurations we sell. And that's good for working with models up to about 300 megabytes if you're looking at the size of the Revit file on disk. If your projects are bigger than that, 32 gigabytes should work for models up to about 700 megabytes. And then if you have even larger projects, you can certainly go higher. It's not unheard of to have 64 or even 128 gigs of memory in a workstation these days for folks that need it. But if you're only working with 300 megabyte models, having 64 gigs of RAM isn't going to do you any good. It doesn't make anything go faster. It's only a problem when you don't have enough of it. That's something I don't really delve into here on this presentation, but it is worth mentioning, is memory speeds are not something you should have to worry about. There are different frequencies of memory available. You'll see things like 2666, 3200, 3600 megahertz memory. And faster memory is marginally faster, but it is usually not the thing that is holding back performance. It's much more a matter of getting memory that is rated, or excuse me, getting memory that's the right speed that a CPU is rated for. You don't want to be running memory that's a ton faster than a CPU is rated for. That's a form of overclocking and can lead to instability. You also don't really want to be running memory that's way slower than a CPU is rated for. That's kind of wasteful, but most system builders should be putting together things where the memory is the correct speed for the CPU you're using. So don't worry a ton about that unless you're building it yourself. And if you're doing that, look at the recommendations from the CPU manufacturer. The controller for memory these days is actually built onto the CPU, so they're the ones that will have the best recommendation for what speed to use. And then again, also back to the topic of capacities, remember that any other applications you have running will also use RAM. So if you think maybe you only need 16 gigs for Revit because you're only using 300 megabyte files, but you tend to have 20 tabs open in Chrome and let's say Zoom for meetings going at the same time, you're probably going to want more than 16 gigs then, just to be safe, because those programs will also need some of their own memory. Moving on from RAM to drives, that's the long-term storage, whereas RAM was the computer's short-term memory. Drives are where things are stored permanently. And there's a couple different technologies. I'm going to kind of go over this. Pardon me if you've been around computers for a long time and know all this stuff. It's still worth covering. The traditional method from going back decades for drive storage is hard drives. HDDs, hard disk drive. It's old spinning metal disks. These days they are pretty cheap and very, very high capacity. You can easily get them in 10, 12, 16 terabyte capacities if you need a lot of space, but they are terribly slow, especially for random access, where the system needs to get data from different parts of the drive. It literally has to wait for the disk to spin to the right place for each section of data. They've also got moving parts, which means they will eventually wear out from mechanical stress, whether that's in just a few years or a couple decades. It will eventually happen. The modern version of storage is solid-state drives, SSDs. It's very similar at a base level to the technology used for storing memory in cameras or in phones these days. And it's very, very fast, but that makes it more expensive per gigabyte than hard drives. There is also a limited number of times each section of memory in Flash can be written to, but drives are built in such a way that they will detect that. So it's not going to write, if you resave the same file over and over, it's not going to hit the same spot on the drive and wear out that spot. It'll actually be written to a new location and sort of do what they call wear leveling, where it spreads out the writes over the whole drive. So that's not generally something you have to worry about practically unless you are doing a lot of writing. Terabytes a day of writing, yes, then you need to worry about that. If you're only writing a handful of gigabytes of data a day, it should never be an issue during the lifespan of the computer. There are also, though, different types of SSDs now, and this is just something that's come up in the last few years, and it's based on the type of connection they're using to the computer. Traditional drives use what's called SATA, serial ATA. That's the same thing hard drives use, and SSDs can use that too, but that connection itself ends up being the bottleneck in performance. What you can do to get around that is to switch to a higher speed connection, which usually is PCI Express. That's the same connection that video cards use or other expansion cards in a computer. And There are solid state drives available that use those same expansion slots, just like a video card. They look like a smaller one, usually without a fan. And there's also a couple other connectors that use that same PCI Express data pathway. You'll see them called M.2 or U.2. Those are two different types of connections that also use that. And collectively, you'll see these types of drives usually referred to as NVMe SSDs, non-volatile memory, I think is what that stands for. But they're basically a special type of SSD, and they themselves are faster, plus the connection they're using is far, far faster. So you can get speeds that are easily 2 to 4 times that of a normal SSD, which is already multiple times faster than a hard drive. And how drives are going to impact Revit and other usage, it's going to impact how quickly Windows boots up, how fast Revit and other programs start up, how long it takes to open or save a model if you're storing locally on the drive. And again, back to the RAM, if you ever did hit a situation where you run out of memory and Windows has to start paging things to the drive, an SSD is far, far better for that, because just the extra speed, it gets way slower than RAM still, but for virtual memory, an SSD is going to be tremendously better than a hard drive if you get in that situation, which of course you want to avoid if possible. And capacity needs vary greatly from one person to another, but in my experience, at least for Revit and a lot of other engineering applications, it's not usually a need for a ton of storage. Again, it really depends on the size and number of models you're working with, but what I've found is common myself anyway, is to have a fairly low amount of storage space in the computer, and then usually an external or network storage for repositories for larger stuff for projects you're not working on currently. But definitely keep in mind what your own individual needs are there. Bottom line these days, though, is there's no reason not to use a solid state drive, especially for the OS and applications and data. They're much, much faster. Prices are getting more and more reasonable as well these days. There is still a role for hard drives, though. Because of the massive amount of storage they offer, they're great for network drives. They're good for backups or just an extra storage drive in the computer if you don't have like network options available to you and you want to have a repository for all your old finished projects, things like that. And then to kind of continue moving past purely Revit itself for a moment to some other related applications. Rendering is one that is a huge thing these days, I think, at least. It comes up a lot when I talk to people. And that's the process, for those who aren't familiar with it, of making photorealistic images or video clips that looks a lot better than just your normal view in Revit. But the trade-off there, and the reason it can look better, is it requires a lot more computation, usually several seconds or even minutes per individual still frame that you're doing. And it also depends on the resolution and how complex your image is and lighting and all sorts of things like that. But there's two main approaches these days toward the hardware side of the rendering needs. And the one that's been around for a couple decades is CPU-based rendering. Again, most things use the CPU. So CPU-based rendering just uses those processor cores you've got to do what's called ray tracing, usually ray tracing or path tracing. And that's just drawing or calculating all of the paths that light follows as it bounces around. And that's what is really happening with photons in the real world. They're trying to emulate that in the process of rendering to make these photorealistic images. And because it's a bunch of little things, a bunch of little individual paths or photons that are being tracked, it actually scales really well to high core count processors. Each of those individual calculations can be done on a separate thread. They don't interfere with each other. So high core count processors are really, really good if you're using CPU-based rendering, and that's what the default rendering engine in Revit uses. There's also GPU-based rendering that uses the video card or even potentially cards and scales really well with faster and multiple cards. And again, like I mentioned, the rendering engine built into Revit is CPU-based, but a lot of people will end up using either a completely separate program for rendering or a plugin within Revit. And a good example of that, one of the common ones that I test a lot, is V-Ray. And V-Ray is kind of interesting in that it actually has both CPU and GPU options. You can go either direction in it depending on what you want to do. And in the most recent version, V-Ray Next, the GPU side will actually also use the CPU. So you can benefit from both high-end and multiple video cards and also a higher-end CPU in that particular one. So if you do a lot of rendering with your workstation, the first step is to figure out which of those two types of rendering engines you're using. Again, if it's what's built into Revit, just the CPU for now, although I suppose that could change somewhere down the road. GPU is getting more and more popular to use. But if you're using a plugin and you're not sure which it uses, check with the software vendor. They should be able to guide you in at least as to which of those two camps it is in. And then for CPU-based rendering engines, consider scaling up to a more powerful CPU. Before, for just core Revit work, you just want high clock speed. You don't need a lot of cores. But if you're going to also be doing a lot of rendering on the same workstation, you want to crank that core count up, particularly if it's something that you find yourself waiting on a lot and you want to save yourself some time. In particular right now, and of course things change from year to year, but right now AMD processors offer some of the highest core count stuff out there. So their Ryzen 9 and Threadrippers are really good. And again, we'll dig into some specific recommendations a little bit later. If you're using a GPU-based rendering engine though, the way to go to scale up to really high performance is multiple video cards. Now, unfortunately, that can get expensive, especially if you're using Quadro video cards. Which usually you want to use for Revit. So depending on your workflow, it's worth considering a separate system entirely. If you're doing a lot of rendering and just have a dedicated rendering box, you can do your Revit work on one system and then throw those files over, usually over a network, to be rendered on another box. And one of the advantages there is most of those GPU rendering engines don't necessarily need you to be running Quadro cards. So you can get away with 3 or 4 GeForce cards for maybe the cost of 1 Quadro and end up getting a lot better performance without compromising your Revit workstation and not having a Quadro there. And then the other main topic I want to talk about outside of Revit is VR, virtual reality. It's gaining in popularity. I've done some testing out here in the office. I actually went ahead and got a VR system for home, not for Revit, just for fun. But it's a really interesting way to immerse yourself inside of a model once you've created it and let people walk around. I find, especially talking to folks doing Revit and other engineering applications and BIM stuff, that it's good for clients. You may not actually want to use it a whole lot. You're used to working in the normal Revit interface, but letting a client see what it's actually going to look like to stand in a room, to look out a window, those sorts of things can be really, really helpful to convey to them what something is going to be like in real life. But that comes with a much more powerful video card requirement. You're going from displaying flat stuff where you're just rotating around and looking at things, zooming in and out, to suddenly a situation where you need to have real-time graphics that are super realistic and also very fluid. As someone's moving their head around, you don't want it to be stuttering. That can be disorienting, and at worst, it can make people sick. And plus, you're not displaying just one screen anymore. You're displaying 2. You're actually making a different image for each eye. That's how you get a stereo effect so that people can actually see depth and things like that. So that's doubling the requirement for processing from the video card there, plus the requirement for a very high frame rate means you really want to go with a high-end video card. And if this is the same system you're doing Revit on, that needs to be a high-end Quadro card in order to have the best compatibility with Revit as well. So that can kind of get pricey. And again, the CPU also does play a role in that. But if you go with our recommendation for a high clock speed CPU, that should be plenty for VR. It doesn't need high core count or anything like that. And then just a caveat on the hardware side, outside of the specs themselves, just in terms of connectivity, it's worth keeping in mind that VR headsets are going to require an additional video output, same as a monitor would. And you need to look and see, there's several different headsets on the market. There's ones from Oculus, from HTC. So you want to make sure that whatever headset you're going to get, you have a free monitor connection for, or if you're buying a PC and a VR headset at the same time, consider what monitors you're going to have and make sure that once you've got all your monitors covered, you've still got a connection of the right type for the headset. And then also, they'll usually require 1 or more USB connections, often USB 3 or higher, in order to transmit data back and forth outside of just the video stream. The headset has to be able to send back tracking data and things like that. There's often usually controllers for controlling movement and options within VR while you're experiencing it. So you want to make sure whatever connections the particular VR headset you want to use has are available on the computer above and beyond the ones you're already going to need for your monitors and keyboard and mouse and other devices. So moving on from kind of that overview to specific hardware recommendations, and again, this is going to change. Intel just literally launched new CPUs this morning, which I'll mention a couple of, but we haven't had a chance to test in Revit yet because of how new they are. So this sort of thing won't age well if you're watching this in a couple of years. Don't follow these recommendations anymore. But for right now and for probably the next 6 to 12 months, these will do. And I'm also going to kind of try and provide some general guidelines so that if you are watching this later on, you can use those and just ignore the specifics. So for the CPU, the general rule is to tailor your selection to what slows you down the most. For a lot of people, that's just going to be general Revit workloads and modeling and VR stuff potentially. And for that, you want, again, a high clock speed. Core count doesn't matter a ton, 6, 8, 10 cores, something in that range will be more than enough. So specifically, we would recommend an Intel Core i7 or Core i9 with a high clock speed. Sometimes you'll find those, especially on laptops with relatively low clock speeds, and that will impact your usage. Some specific examples available today would be like the Core i7 9700K or i9 9900K, which have just been replaced as of today, though it'll take a few months for this to really work its way into the market, with the 10700K and 10900K. Or if you're on the AMD side of things, they make great processors nowadays too. Any of their Ryzen 7 or Ryzen 9 chips, again with a high clock speed, and particularly the 3rd generation chips. You can still find some older 2nd and 1st gen ones that aren't as good, but the 3rd gen ones, which will start with a 3 in the model name, are all pretty solid. And then if you're going more rendering focused, or if you're building a separate workstation for rendering, if it's the CPU side of things, AMD's Ryzen 9 3950X is a fantastic one. That's the top end of their Ryzen line right now, 16 cores. So it does really, really well. More cores than you need for just Revit, but fantastic for rendering. And then any of their 3rd gen Threadripper chips, those have 24 up to 64 cores, and they are phenomenal, but they get more expensive. They're in the $1,000 plus price range just for the CPU. And then again, something to consider as you're kind of working your way through is keeping your budget in mind, because both the CPU and the GPU are going to be probably the most expensive parts of your computer. And you want to keep a good balance there. You don't want to spend way more on the CPU and then not be able to afford a Quadro video card. Likewise, you don't want to skimp on the CPU to get a massive video card and then be limited by the CPU. And something worth mentioning to avoid for most normal Revit uses is dual CPU systems. Those tend to have lower clock speeds. There's a few exceptions, but for the most part, dual CPU systems are more aimed at servers and some specialized applications like that. And they tend to have low clock speeds, which is not what you want for Revit, and especially not for VR and whatnot. There can be places where they make sense for rendering, but in general, it's just going to cost you a lot more and not provide you a benefit in this particular workflow. Then onto the GPU, general rule is whatever certified video card best fits your budget. As we saw, all the way down to a P1000 Quadro card can be viable if you're not working with really large models, and certainly if you're not in VR. Our specific recommendation, though, these days is the most affordable of the Quadro RTX series cards. It's the latest generation cards from NVIDIA on the Quadro side. They've got some new features that aren't really used in Revit yet, but may. Some actual real-time ray tracing stuff. They're starting to move toward doing a lot of the things that you see in rendering in real time. And this is the entry-level card in the Quadro line that has that support. It's also just a solid general all-around card. It's got multiple monitor outputs. It's only a single slot, so it doesn't take up a whole lot of space in the computer. Just a very good all-around choice. But it is worth considering going higher, again, particularly if you're working with VR stuff. Maybe bump up to like the RTX 5000, or if you're working with really, really massive models within Revit. Nothing that we've thrown at it needed more than an RTX 4000, but I'm sure there are people working with stuff bigger than what we test with. And then multiple GPUs really is only if you're using GPU-based rendering. And again, also worth considering a separate system for that if that is the direction you're going. And avoid, if possible, the NVIDIA GeForce series, primarily because it's not certified. You don't want to end up in a situation where you can't get help from Autodesk because you're not using certified hardware, or where some weird bug comes up and they're not going to fix it or address it right away, again, because it's not certified. Again, with the caveat that if you're doing GPU rendering, and especially on a dedicated system, they can make a lot of sense. They have great horsepower, they just aren't as well vetted for use with professional applications. And then on to RAM. General rules, more RAM as your Revit models get larger, and you can look at the file size on disk to judge that, at least to some degree. For specific recommendations, 16 gig is an absolute minimum in our opinion. 32 gig is usually safe for most Revit users. And then if you know you're working with really large projects, stuff like up above 700 megabytes on disk or whatnot, or if you're doing heavy multitasking or going to be doing big CPU rendering jobs, feel free to go with more. Something that's worth considering, no matter what size of RAM you get, is trying to leave open slots for more memory in the future. Most motherboards, and it can be a little tricky to find if you're buying like an off-the-shelf system to get these details, but most motherboards will have several slots, anywhere from 4 to 8, sometimes even more than that. And if you can populate only part of those with what you think is enough memory for what you're doing, that gives you flexibility down the road as you get bigger projects, or if Revit's needs change, or if your workflow changes, to be able to add in more memory without having to take out the memory that's in there and waste it. So it's not crucial, but it's worth considering. And then again, what to avoid: overspending on excess memory. If you're only working with small files in Revit, you don't need 128 gigs of RAM. You're just going to be wasting money that could be better spent elsewhere. And then on to the drives. General rule would be use solid state drives, if at all possible, for the OS applications and files. They're affordable enough now that there's really no reason not to do this. And you want to cover and make sure the OS, so that it boots quickly, the applications that they launch quickly, and the working files, things you're working with day to day, are all on those to get the best speed. Our specific recommendation would be a Samsung 970 series NVMe drives. SATA drives are okay too if you're on a budget, but Samsung, in our experience, has been particularly reliable. We've got data on them going back years and years now, and they're one of the lowest failure rate components we've ever seen here at Puget Systems. As far as size, 500 gig is what I usually recommend as a good starting point, but depending on your specific needs, you may want more than that. You also may want to consider multiple drives. It's a popular way to go, to have like a 500 gig drive for Windows and applications, and then another 500 gig or 1 terabyte drive just for just for files. It's entirely up to you. There's lots of flexibility there in most systems for having multiple drives, and it really comes down to kind of your workflow. And then again, to avoid, don't forget to back up your data. Whatever else you're doing, you want to make sure you have at least one more copy of any important files that you're working on, ideally a couple, one extra in the computer or nearby, and then one somewhere safe online or off-site or whatnot. And that's actually, again, one place where hard drives are okay. If you're just talking about backing up a bunch of data, hard drives are fine for that. And then some other general system configuration considerations. You want to make sure you got a good quality power supply and plenty of cooling. Those are going to affect the reliability of the system. They're not going to directly affect performance, but if you don't have enough cooling, the hardware is going to get too hot, which will degrade its lifespan, or potentially slow it down. Some components like the CPU and video card will slow down if they get too hot. And the power supply, if that thing goes out, it can take other components with it, plus just the reliability aspect. If the power supply fails at some point, you're going to lose some work while you're waiting for it to be replaced. So having a good one that's not going to go out for years and years is really worthwhile, even if it costs a little bit more money. And then ensure the system supports the right sort of networking for what you're doing, whether that's wired network, Wi-Fi, and if it's wired, what speed of infrastructure do you have? If you've got a 10 gig network in your office, you want to get a system that's got support for 10 gig networking, or you're just wasting a lot of the network bandwidth that you have. Likewise, if you're only got a 1 gig or, God forbid, a 100 meg network in your office, spending a bunch of money on a 10 gig network card isn't going to give you any benefit. So you want to make sure it's the right network configuration for what you're doing. And then if you're using multiple monitors or a VR headset, you want to check and make sure the number and type of video outputs you have on your card are going to match up with what you need. Most Quadro cards have gone over to using DisplayPort connections as kind of their standard, and you can adapt from those to HDMI or DVI if you need to, but you might need to purchase extra adapter cables. So that's something to keep in mind. And getting plenty of USB ports is always nice. There are ways to use hubs and things to increase that, but we've found a lot of times, especially unpowered hubs can increase system instability and introduce other weird issues. So ideally, if possible, make sure you have enough USB ports right on the computer for everything you need to plug in, and that saves you a lot of headache. And then lastly, just some tips on how to get the best value for your money. Kind of some general stuff. One is to avoid off-the-shelf systems. You're just going down to Best Buy or Fry's if you still have those in your area. A lot of the systems on the shelf there are going to be underpowered in terms of hardware for Revit specifically. They're usually not going to have Quadro cards. They're not going to have super high-end CPUs or a lot of extra space for things like more memory. And they also often will have barely enough of a power supply to run what hardware that's there. So if you're like, oh, I'll get an off-the-shelf system and put a Quadro in it, maybe, but you also may need to replace the power supply then. And a lot of times they use proprietary stuff as well, which can make that difficult. So I recommend instead working with a system builder that offers both great hardware and support. And there are lots of those out there. We are not the only one by any means. But you know, you can get the fastest system in the world, but if it's actually not running for some reason, if it's got some weird issue going on with Windows or your software or something, that's not going to do you any good. So you want a company that's going to provide responsive and knowledgeable tech support, because that's going to save you time and money in the long run. And then also don't let folks upsell you. If you've gone through something like this or have researched it on your own and have a really good idea of what you want, don't let yourself get talked into something more expensive unless they can really back that up with Revit specific test data. And then again, just a guideline for the way I go about it if I'm configuring a system for someone is start off with a suitable CPU. Again, high clock speed, just a few cores, or increase the core count if you're going to be doing rendering, and then pick a good video card, one that's going to fit in your budget and handle the level of assemblies or level of models that you're working with. If you can't afford a Quadro, you can go with a GeForce in a pinch, but again, I recommend avoiding that. And then once you've got those, then go for the RAM and drive, make sure those are large enough for what you're doing, and work your way through that way. So in summary, pick a CPU, pick a GPU, and again, stick with the certified stuff. I just checked today just to double check before the presentation here, and all of the current P series and RTX series Quadros are on the official certified list for Revit 2020. Make sure to get a sufficient size SSD and enough RAM with room to grow. Use a system builder who has experience with Revit and offers good support. And then we're here to help. Whether you're buying a system from us or not, you can look at all the articles we've got on our website. You can look at presentations like this and other ones that we've done in the past. And if you are able to buy one from us, great. We've got consultants that are that are trained to help folks get the right system for them. We don't do upselling. We're not on commission. Especially personally don't like that. I was one of our consultants for 9 years, so I've got a lot of experience in that department, and they will do a great job helping out without pressuring you. So yeah, if you have any questions and haven't had a chance to already, again, there's a reminder of where the question button is, and I'm going to try and see if I can see where those things are. Let's see here. I'm not...
Hey, William, do you want me to give you a hand and do a little moderating of those?
Yeah, if you would like to. It looks like there's also some questions coming up in the actual Zoom chat too. So
yeah, there's been a couple of chats. There was only one real question in there. There's a couple of things that jump out at me. I think we've got time to get to most things. Maybe I'll. Sure. There was one that you actually covered. There was a question about when you're writing from memory, when you're running out of memory and you're writing to disk. The question was, are we talking about a mechanical hard drive or an SSD? And you pretty much covered it. It's going to be whatever your system has, right?
Yeah, so it's by default. If you don't touch anything, Windows will put that on the C drive usually. So whatever your primary system drive is where that will be. That is one of those things where if you've got a faster drive in your system, like let's say for whatever reason you end up with a SATA-based SSD for the OS and applications, but you've got a really fast NVMe drive for your project files, it's worth going into Windows and telling Windows, hey, use this other drive if you ever do need to for virtual memory. You want to, if possible, have that on the fastest drive. Windows just assumes that's usually going to be your C drive. Yeah.
Okay, and there's a couple of other things that also were sort of, I think, pretty well covered in your very good presentation. But there's a couple of things that are kind of specific. Like one was, can multiple instances of Revit running at the same time access multiple video cards, or do they all share the individual card?
I have actually never tried that, but I believe, just thinking through how that would work and other similar programs, I believe they will share whatever the card that's being used to display on the specific monitor where that Revit window is running is. So you can, I don't recommend this for Revit especially, but you can potentially have multiple video cards in your system, each one connected to a different monitor. You don't need to do that. One video card will usually output anywhere from 2 to 4 monitors, depending on the specific card and what ports it has. But you could theoretically have 2 cards connected to 2 separate monitors. And then if you were running 2 instances of Revit, one on each monitor, they would be using separate video cards. But if you had both monitors connected to a single card, then they would both be running off that one card. It's really whatever monitor, or excuse me, whatever video card is powering the monitor where Revit is being displayed.
Oh, that's very interesting. I've never really thought about that. My only experience with multiple GPUs and splitting them up has to do with virtualization, which is completely different. But
Yeah.
There's also a question about, would love to get your thoughts on a RAID setup on PCs. Tend to partition my drives, C drive for OS and programs, D drive for my data, and thoughts on this setup.
Yeah, that's that specific setup, the C and D drives separately for those things, is really common, one that we see a lot. And it actually has some, just a side point, it has some nice benefits. If you ever need to reinstall Windows and you have to flatten your C drive to do it, you don't have to worry about moving your data first if it's off on a separate drive. You'll always have to reinstall your programs and such, of course, but that can be nice not to have to worry about where are all my files stored, moving them off before reinstalling Windows so you don't lose anything. As far as RAID goes, so just a little background for people, RAID stands for Redundant Array of Independent Disks. And there's actually several different RAID modes, and some of them actually aren't redundant despite the name. The most common ones people are usually talking about are RAID 0, which is striping, where you take 2 drives and you put half of your data on each drive. You're not manually doing this, the OS and the drivers are handling it for you. But that can give a speed benefit because now you're effectively doubling the speed that your data is written and read at. But the downside is if either one of those drives fails, you've lost exactly half of all your files, which means it's unrecoverable. The stuff that's left there is just garbled. So that doesn't provide redundancy, but does provide speed. The other common one is RAID 1, which is called mirroring. That's where you're making 2 different drives have an exact copy of everything, and that's for, well, redundancy primarily. It does increase the speed you can read at because you can read half of a file from each drive at the same time, but it doesn't increase write speed. You have to write to both drives simultaneously. So you get some performance benefit, but you get redundancy. And that can be nice, especially if for some reason you can't have another backup that's readily available. I don't consider RAID to be as good as having a separate backup, but it can be an alternative or an extra layer of data protection if you want. At the same time, though, with solid state drives especially if you're using a good brand like Samsung, we see failure rates in the fractions of a percent, like super duper low failure rates. So having that extra layer of protection with solid state drives is probably more overkill than anything else. But if you're doing it for speed, that's legitimate. Just make sure you have a backup, especially if you're using RAID 0. You don't want to trust that for data integrity because of the risk of data loss. And there are more advanced RAID modes as well, RAID 5, 6, 10, that probably are beyond the scope of this. We actually have, if you're really curious, we have a really good article. It's old now, but RAID modes haven't changed in a long time on our website that describes all the different modes. And then we have some data on our website too about performance as you scale up, because you can have even more than 2 drives in an array. So there's a lot there. And that's also one of those things our consultants can help with. If you're looking to buy a new system, they can talk to you about the specifics of your unique situation and what makes sense.
Awesome. Yeah, that's a really good plug for your website. I have gone through there and there's quite a bit of information that are really, really good, insightful articles. I'm going to try to get, we've got enough time. I'm going to try to get through most of these. I'll get maybe to a quick one over here, which probably is in everybody's minds, is what is the minimum clock speed you would recommend for a CPU for Revit?
Okay, it's a little tricky these days. If you go back 5 or 6 years, you would just see a clock speed listed on a CPU, and that would be the speed that it normally ran at, and it would only run slower than that if it got too hot or something like that. Or if it was, you're not using it, it'll bump down to a lower speed to save power. But nowadays, it's gotten trickier because almost every CPU out there will have a base clock speed, and then will also advertise turbo speeds. And so what they do nowadays, there's sort of a nominal speed that the CPU tries to run at, and then when you're actually doing something, if it's got headroom in terms of power and temperature, it will go up toward the turbo speed. And depending on what site you're looking at, sometimes they only show the turbo speed, sometimes they only show the base, sometimes they'll show both. So this gets to be a bit of a confusing question, but I would say ideally a CPU that is actually going to run at 4 gigahertz or higher during normal operation. So you want to look at probably the turbo speed, and if that's in the mid 4 gigahertz range or higher, should be fine. As it goes down, that'll be a little bit lower performance. I wouldn't get anything that has a turbo speed below 4 gigahertz, but a lot of times you will see the base clock speed way below 4 gigahertz, like a 3.5 gigahertz or something base clock, and then it turbos up to 4.5. So it can be tricky to find that information. The best, like the most reliable sources go straight to the manufacturer. Intel's ARC page, ARK, they've got they basically list every CPU they've made for ages there. So it's a little tricky to drill down and find the one you're looking for. But if you can find it on there, that will list very specifically what the maximum turbo is, what the base is, and you can use that. AMD's website is also really good. I don't think they have a particular name for where they keep their specifications, but you can find that there. You can also find that on our website for the CPUs we carry. We don't carry every CPU out there by any means. So depending on what you're looking for, we may not have the information, but the ones that we carry, we do list all of that for them. And it's worth noting, just because you're actually running something and the system's not overheating or anything, it's not like you're always going to get the turbo speed either. The turbo speed is usually the maximum that it will run at if one core is active. And so for Revit, that is actually usually going to be what you get. But if you have 2 or 3 or 4 cores or all your cores active, the turbo speed will gradually go down. And sometimes you'll even see listed like a max all core turbo speed, and that'll be the bottom end of the turbo range. So it's gotten tricky over the last few generations. But if you can find something that's got a turbo speed in the mid 4 gigahertz or higher range, that should be a safe spot.
Awesome. And actually that's a good topic, because I tend to find a lot of the offerings from, let's call them the big enterprise guys out there. They have a little bit of a different view of what an engineering workstation is, and a lot of times they might be geared towards like MCAD or CATIA, yep, SolidWorks, stuff like that. And what I have found in speccing machines out is that oftentimes those machines are built with a lot of reliability and redundancy in mind, but they tend to use almost server type CPUs where there's a lot of cores, a lot of threads. Clock speeds tend to be far below what you would really want.
Yep.
So question here, as well as some of these recommendations that we talked about, do they also apply to other Autodesk suite programs like AutoCAD and 3ds Max? Obviously 3ds Max is going to be more of a rendering thing, right? But how about AutoCAD? AutoCAD's a little bit of a, we don't like to bring up the A word around the Revit user group, but the reality is people still use it for certain things.
Sure. It's fairly similar. Almost every program out there that is doing parametric modeling, in other words, where whatever you're displaying on screen is based on specific parameters that you can input, is going to be fairly single-threaded. And part of the reason is, if you change one parameter, you change the length of something or the height of a door, it has to then cascade out and go, okay, well, that changed, so I need to change this other thing, which means I need to change this other thing. And it's a very serial process. You can't jump ahead and calculate this other thing that needs to change until you've done the other steps first. And that's part of why a lot of these programs tend to be very single-threaded. in the modeling side of things. And AutoCAD, as far as I understand, and the limited testing that I've done on that, is that same way. The biggest thing with AutoCAD is usually even lower graphics requirements. It depends on what you're modeling in there, but a lot of people will use AutoCAD for just purely 2D stuff and things like that, and needs even less power from the video card effectively then. If you go over more into things like 3ds Max or Maya, again, for the modeling side, things hold true, but those also do usually land you more in the rendering space like you were mentioning, and those will also offer sometimes physics calculations or simulations and things that can be done. So you kind of, requirements can definitely vary. I would check with both resources related to that, online reviews or articles, and YouTube actually is a fantastic place these days for getting information about that sort of stuff. And then specifically any plugins. That's something I actually probably should have mentioned in the main thing. If you're using any plugins within, whether it's Revit or 3ds Max or whatnot, those can also change the needs, because those plugins are written by usually a completely different company, and you want to find out from them how the calculations are being done and how that's going to behave on hardware and what its needs are.
Excellent. Well, we are almost out of time, but I think there's one more question here that's kind of pertinent. There's a couple of things here about, SLI and NVLink and things like that. And we've talked about, the multiple GPUs. So maybe I'll skip that. And what I would say is maybe we can maybe offline some of these questions and put them on the comments on the YouTube channel when we post this up. But there is one thing here that kind of caught my eye, which is asking if you're running multiple versions of Revit, although I would extend this question to be, multiple instances of Revit.
Oh,
Can
okay.
you push those onto multiple cores? So one instance running on, one core, another instance in another core.
Windows will do that by default. Windows manages how the cores are used and what programs are running on what. And yeah, if you've got multiple instances of software running, it's not going to try and pile those all on one core, thankfully. It'll handle that fairly well, and there's some quirks to how Windows does that. When you get up to really heavily threaded stuff, sometimes Windows doesn't behave super well, but when you're talking about things like this, yeah, it'll do fine that. And just a quick note on the NVLink question, go to our website, type in, search for NVLink, you'll find more than enough information, and we address all those questions you asked. I see that question there.
Excellent. Yeah, and there was, also obviously this has been very focused on desktop hardware. There was a comment about laptops, which in my view kind of limit you a lot more. Laptops kind of are what they are. I'm sure that you've got, your preferred setups and your preferred configurations, but they're not something that's as flexible. Yeah,
the biggest thing there, you're definitely going to end up with a CPU and video card that aren't as powerful as you could get in a desktop, purely because of power and cooling requirements. So you have to run off a battery or a wall adapter, and you have to cool with little teeny tiny fans instead of nice big like 120 millimeter fans. So just there, you're going to have some performance limitations, but you can still go by a lot of these things, try to find something with a fairly high clock speed, try to get a good video card. The biggest thing that I would say changes about my recommendations for a laptop is you can't count on being able to add more drives or more memory or upgrade the video card later on, things like that you can in a desktop. So make sure you get all of those adequately covered in the base system you buy, because you're probably not going to be opening up and tinkering with it.
Yeah, absolutely. Well, William, I really want to thank you, and Puget Systems has been a really great presentation, and I want to thank everybody for attending. We're up against the clock here, so we'll wrap it up, but I really want to say thank you. This is really, really great information. So, we will see you again in our for our June presentation, which will be, I believe, the 17th of June. Absolutely. And Microsoft Resources will be hosting and presenting. So look forward to seeing you then, and look forward to putting together a presentation for that month with Microsoft. So thank you so much, everybody. Have a great afternoon and enjoy the rest of your day. Bye-bye.